So, time to learn why emphysema is a obstructive disorder, because lungs to ज़्यादा बड़े हो रहे, or whatever the reason, like people think, but it is an obstructive disorder. It's a dynamic outflow obstruction. I'll tell you why. These are your lungs. They are covered by pleura. I mean, reflect here also, but they're covered by pleura. Now look at this interface here. You will have lungs, you will have your pleura, you will have your intrapleural space, or basically your lung is, this is your lung, this is the, you will have one covering of pleura here and then another covering of pleura here. So this will be the intrapleural pressure. Here inside the lung you will have the alveoli. So here you will have alveolar pressure. Here you will have the pleural pressure or intrapleural pressure or whatever. Now what will be the difference here in the pressures? That we call the transpulmonary pressure. Now this transpulmonary pressure is what takes you to the next step. Is one sentence that I like. Now when we begin to inspire, before inspiration, at rest, what will be your transpulmonary pressure? It will be alveolar pressure minus pleural pressure. What will be the alveolar pressure at rest? It is 0 centimeters of water. Minus, what will the pleural pressure? The pleural pressure, the lung, this is connected to the chest wall. Chest wall always wants to expand, lungs always want to collapse. So this will go here, this will go here. So here there will be a void, or there's something like, I don't know how, if you can imagine it, but here you will have a negative pressure. You have to imagine that. So it will be around minus 5 centimeters of water. And so you will get this as plus 5 centimeters of water. Now, you started inspiration, then you will have to end inspiration. Correct? So your pleural pressure, your alveolar pressure actually, the alveolar pressure while you are expanding the lungs, the alveolar pressure will go down. But if this is your entire inspiration, it will be like this. So if this was 0 and this was 0, it will come back to 0. So this is at rest. Now at the end of inspiration, what is transpulmonary pressure? It will be, the alveolar pressure will come back to 0 at the end of inspiration. It will go down, but it will come back to 0. So 0 minus. Now what is the pleural pressure? The pleural pressure, now chest wall is going there. The alveoli have come back to 0, but at the end of inspiration, the chest wall is still here only. Alveoli have come back to 0, but chest wall is still a little more expanded. So it will become more negative. So here you will have, instead of minus 5, it will be more negative. So you have minus 10. So this is plus 10. So at the end of inspiration, imagine you have inspired, chest wall is above, the alveoli have come back to 0, but your pleural pressure is now minus 10. So transpulmonary pressure will be plus 10. So this pressure, now there's a pressure like this. Now if you do a forced expiration, a normal expiration or forced expiration, we are saying that chalo, the alveoli are collapsing. Not the alveoli, the airways are collapsing. So in forced expiration, what will happen? Let's imagine, what was the transpulmonary pressure? It was 10 that we found out at the end of inspiration. Take that 10 is equals to, what will be the alveolar pressure? Let's find out. We don't know what will happen to the alveoli at the end of expiration, but what do we know? That this transpulmonary pressure will be way more. It will be positive. Let's take an arbitrary value like plus 30. So the alveolar pressure will be 40. Now if you are asking me why will it be plus 30? In emphysema, the compliance decreases. So the lungs will want to expand like that. We are saying that the compliance is increasing, the lung is expanding more. Now say this was the chest wall, this was the lung. Here you have negative pressure. Say this moves closer. Will the pressure now be positive? It will be less negative, no? Because it was negative because this was going here, this was going here. The stretching was causing the stretching in opposite directions was causing negative pressure. Now the stretching is not there, so this will be less negative or more positive. That was one. Now imagine you are doing expiration very forcefully. So if you are expiring very forcefully, it will be, this will come here, so this will also come here. So this will come here, this will also come here. So here it becomes around plus 30. So alveolar will be 40. Now this concept now we will have to add. Force expiration we got the plus 40. But say this pressure became different. This pressure will decrease in your emphysema. How? Because at rest, this pleural pressure, I am saying here that it will become less negative. So instead of -5, it will become -3. So this will be +3. Now, if you add this thing here, the alveoli will be here. Transpulmonary, we got 10. Now what we will get? Say it's still -3 only. Leave this somewhere, make this +3. So this will be +3. So now the alveolar pressure will be 33. Correct? Now let's see what that 33 is causing. Say that this is your alveoli, this is your pleura. Now pleural pressure at the force expression, we are saying it's 30, 30, 30, 30, 30. Here we said it was 40. Now this will go on decreasing, 33, 30, fine. This is the equal pressure point. 23 here, if here this is 30 and here it is 23, this will collapse. But in a normal lung there is some C-shaped cartilage which is not allowing it to collapse. Now if this became 33, what will happen? This will be 30. So the equal pressure point will come closer to the alveoli. The more closer or proximal you come to the alveoli, you will have lesser cartilaginous protection. So here if the cartilage is not protecting your airway, it will collapse. This is why we say that emphysema is a obstructive disease.